This is Arsha from Mental, and today we're going to talk about one very important question, and that is why the network is needed. So, why do we need the network? Well, let me tell you something. If you take a look at these paint I've created, we've got a corporation, for example, they've got two clients on the corporation, right? PC1 and PC2 are our clients. And they were working in different areas. For example, PC1 was in IT field and was the third floor, and the PC2 was in the security section, was in the first floor. And there was something that PC1 had to send to PC2 to notify them that there is a change in the corporation. So they have to know it. But there was a problem. There weren't anything to copy the data from PC1 to PC2. And back in those days, like in the year 1970s or 1960s, that was the year that we had floppy disks. So we had a guy, and he had to physically use a floppy disk, copy the data from the PC1, and then go to the first floor to send the data to PC2 physically. And that's a problem. That's okay if you got a corporation with 10 clients or 15 clients. But how about if we had a corporation with more than 50 or 500 clients? Well, that would be a real problem, isn't it? So the need of network was there from a very long time ago. And that was the first thing, the standalone clients. There was no media to share files. That was a great problem. So the first thing that was created was the bus topology. So what is bus topology? Bus topology was our first topology on networking, and it's telling me that there was a client. Let me make it here. All right, PC1 is here, and it's connected using a T connector, and there's PC2 in here. Both PCs had NIC, which stands for the network interface cards. So the network interface card was created in order to send the data, no matter how you want to send the data, no matter the topology you had. NIC was there. It was built in on the motherboard. You can actually buy dedicated NIC as well, but it's mostly dedicated. It's mostly on board on your motherboard. So the PC1 and PC2 had NICs, and they were about to send data to each other using the bus topology. So bus was basically a coaxial cable between the PC1 and PC2, and they had T connectors so that these two PCs, for example, if it was the motherboard from PC1, it could be a T connector, and it would convert the coaxial cable to the connector of the motherboard, so they could actually send the data to each other. So using the T connector, there was the data that was being sent to each other, but there was a greater problem. You see, the electricity, when it was about to flow in the bus topology, flow in the coaxial cable, the T connector had a problem. The T connector had two open ports, and the electricity could actually flow out using these ports because they were open. So they came out with a conclusion that, hold on a minute, we need to fix this problem, and they used terminators. But terminators were like doors for these T connectors, so they could make sure that there is no electricity going out of these connectors. So now we can make sure that when PC1 actually he sent any kind of electricity signal to PC2, PC2 would actually send the data. And when there is electricity in the cable, the binary number would be 1, and if there isn't, the binary number would be 0. And that's very important for you to know that from the Network Plus course. So they could actually talk to each other now, but there was another problem, and that's the fact that we call it the single point of failure. If anywhere in this coaxial cable of the bus topology would find out a problem, for example, if the cable goes down, I don't know, if it's being eaten by an animal or whatever it is, well, the whole clients, I mean all of them, would lose the connectivity. So that's what we call the single point of failure. It's a single point that causes to a failure. And if the failure happens, it's gonna be, the whole network is going to be down. So that's a real problem. And there's still another problem. The other problem is that the bus topology using coaxial cable was just nice for, some specific distance. For example, for 40 meters, for 20 meters, if there was a distance between, if PC1 was 20 meters far away from PC2, that was fine. We could use a coaxial cable. But how if PC2 was 100 meters away, or even more than that? Well, if the normal flow was like this on a 40-meter distance, on a 100-meter it would be something like this. So the PC2 wouldn't actually receive the data, and that's a real problem. So they end up making the star topology. The star topology is using a device called hub, and hub was using a cable called the two-set pair. So the new cable were called two-set pairs, and you have to be familiar from the Network Plus course. They were using the connectors called the RJ45 instead of a bloody coaxial cables, which had so many problems. So two-set pair cables were there. They were better. They could actually support longer distances, and they were faster cables. So here's the thing. Client 1 had RJ45 connector on the motherboard. Here's the RJ45. You have to know it from the Network Plus. Again, you can search it on Google. It was connected to a port. These open ports from hub could be a 4-port hub or an 8-port, whatever it is. And every single client using an RJ45 connector is connected to any of these ports. So here's the problem. If client 3 sends any data to the hub, and if it wants to connect to client A or client 1, the hub would say, hold on a minute, I'm not really that intelligent. I just know if any data being sent to any of my ports, I'm gonna send it to other ports as well. So if you want to connect to client 1, the problem is that client 2 would also get the package that you've sent before. So here's the package. You're sending it to the port 1, but hub is going to flood the package to other ports as well. So what's the problem? Well, this is a real security vulnerability. Why? Why? Because there could be an attacker here. All right. Sorry, I'm not really good with painting. Whatever. If there are any open ports in here, he could actually connect himself to an open port to the hub. So if you send any packages to any client, he would also take a copy of that. And he also would receive one. So, well, that's a real security vulnerability, isn't it? Well, that's hub. It says if I'm getting the package from this port, I'm not sending it to this port, but I'm sending it to other ports. So that's why we end up having switches these days. And switches are a bit more intelligent. I mean, they are intelligent, but not always. And we'll learn about switches in our next episode. So earlier we've talked about why the network is needed, but we're going to actually cover this in more details. So you've got a basic knowledge of topologies right now. And I'm going to tell you how can actually they can make our life easier in the corporation. So imagine if the guy wanted to copy the data, or he wanted to print a paper using a printer. He had to go to the third floor and use the computer in which the printer was connected to. But right now, with the usage of topologies this day, imagine if we got a printer here. If this is our printer or the print server, this printer is directly connected to the hub, and it has an IP address. So client 3, if he wants to print any papers, he could just simply search the IP address of the print server and send his print process to the print server. And the and the printer would actually redirect the traffic to the first printer, whatever it is, and it would actually print your paper. And there is no more needed for you to physically go to client A, then just hit the print key and get the paper and get back to your office again. That's ridiculous. Or imagine the first scenario that we were talking about, the floppy disks, and that guy, he had to go to the first floor and the third floor in order to copy a data. But right now we got FTP servers, for example, and these servers still again got an IP address, and they're connected to the hub again, or the switch, or whatever it is. So if I wanted to copy a data, for example, client 3 wants to copy a data, this is a file. It will send it to the FTP server using the FTP server IP address, and it would save in FTP server's local hard disk. So if client 2 want to see the data from the client 3, he would just simply search the IP address of the FTP server, and his data would go through the FTP server, and he could see the data that was stored earlier from the client 3. So it's actually centralized now, and well, that's the most case usage of our network today.